So welcome to this short video on inclination of lines. Inclination means you would often be told that the line is inclined at 30 degree to HP, 40 degree to VP. Yeah, okay, so we are sort of investigating such a situation. Okay, to make the situation a lot more clear, let me take this context. Let us say there is a line AB. A and B are the endpoints of it. Further, suppose that the point A is already identified. We know we have identified its projections. Okay, and now we have to find B, of course, and for that the conditions are that the line is inclined at an angle of alpha to HP and angle of beta to VP. Okay, so the way to solve is we for example, if you take this alpha degrees to HP, what we do is okay, we identify a set of lines. Okay, okay, all of them have their I mean all one of their points is going to be point A. Okay, the other point okay, is such that the line is inclined at alpha to HP. We collect all such lines. Okay, and when we collect it, they form a cone. Okay, this is something we had seen with a lot of detail in while solving one of the previous problems. Okay, I think I can just illustrate it. So here is the example. Okay, so you can see this red line. Okay, so every position of red line has the same inclination with HP. It has all of them have the common point at A. Okay, A is the apex point of this cone. Okay, and so all these lines are all have the same inclination with HP. Okay, yeah, but same inclination with HP. Okay, um, okay, so we don't know which line is the line that we are looking for. Okay, so we will move on to the next condition. The line is also inclined at an angle of beta to VP. Okay, then again, if you collect all the lines which have one point at A, and have an inclination of beta with VP, then the collection of all those lines again would form a cone, and that is shown as a blue cone here. Okay, so here also, if you pick out any line on this blue cone, so for example, this is a blue line that you're seeing. Okay, any of the line, these are all the slant lines, any line. So any of these line would make an angle of beta with the VP. Okay, so again, we right now we don't know which line to pick. Okay, so the line that we are looking for has to satisfy both the conditions. Okay, it is inclined at alpha with HP and beta with VP, so it means it has to lie on both these cones. Okay, only then it can satisfy. So it means these two cones have to intersect, and the lines that we are looking at would lie at the intersection. Okay, um, okay, okay, right. So this is how this is where the lines would lie at the intersection of the two cones. Okay, so this was the kind of strategy we were using to solve this problem. Now the question is, are there a situation where the cones don't intersect at all? It's not very hard to see. So for example, here there are two cones which are intersecting. Now let me change alpha and beta. Okay, so I'm sort of changing alpha, I'm changing beta also. Okay, so okay, you see there is a situation where the cones don't intersect at all. Okay, so so for example, for here the alpha I have taken as 48 and the beta as 52. Now okay, so if there is a question which says that find a line passing through point A, uh, having length of 10 mm. No, let me say like this. Okay, so if you have um, 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 so if you have you know uh, you know, how do I do this? Okay, so if you have a problem like this, there is a line. Okay, there is a line with one end at A. Okay, um, okay, A is 10 mm above HP and 30 mm in front of VP. Okay, uh, okay, AB is equal to 20 mm is equal to 20 mm. Okay, and inclination of AB with HP is so what is that angle that we saw? Okay, um, okay, so okay, say 54.6 and 46.8. Okay, 54.6 and with VP is I think what is that, 46.8. Okay, so if a problem like this is if the problem like this is given, okay, so there is actually no solution because the cones as you are seeing here they don't intersect, so these values represents alpha and beta. Alpha is 54.6, beta is 46.8. Okay, for some set, say for example, for some set of values it seems to intersect, for some set it doesn't. Okay, so how do we know? So what is the condition in alpha and beta by which we can say that yes, the cones do intersect and we have a solution? Okay, so what are the conditions in alpha and beta? So before we get into it, we normally restrict ourselves for alpha and beta to be between 0 and 90 degree. Okay, all right. Okay, uh, okay, so let me see. The thing is, if you look at this particular I think so if you look at this particular the cone where we change the alpha and beta, you see that it is this profile view, which would be able to tell whether there's intersection or not. See here, there's an overlap between the blue cone and the red cone, which means that they are intersecting. But in this case, so what has happened is they no longer intersect. So a gap has been formed. Uh, so a gap has been formed between them. Okay, so. Uh, so it seems that compared to the front view and the top view, we would rather look at the profile view to investigate how the actual uh, whether the cones intersect or not. Okay, and that is not a very hard thing to do. Okay, so uh, let me uh, switch to my mobile phone. Okay, so I'm just going to draw the projections on the profile plane. So this is one axis of the profile plane, and this is another axis of the profile plane. Okay, so this is the profile plane. So this actually would represent the projection of HP, this line, and this represents the projection of VP in the profile plane. Okay, and the cone which is actually perpendicular to HP, okay, is actually, let's say this is the cone. Okay, uh, okay, so this is the cone. Okay, right, so its axis is perpendicular to HP. Okay. uh, okay. And actually, so in this cone, can we identify alpha? So actually this is actually alpha. Okay, and this one actually people also call it as half apex angle, so which I will call it as, which is actually 90 minus alpha. Okay, so far so good. Okay, then let us write the other cone. I think things are becoming little cramped. Okay, what I will do is I will just shift this portion. Okay, let me see how well it works. Okay, alright. Okay, so next let me sort of draw uh, you know the cone which represent the inclination with VP. Okay, so um, so I think roughly somewhere here. Okay, so this is the other cone which represents the inclination with VP. Okay, so and here actually this angle would represent beta. Okay, and the half apex angle, which is actually this angle, so this would actually represent a 90 minus beta. Okay, uh, okay, so if you sort of look at it carefully. Okay, uh, see see here actually the two cones have intersected, so this is the region of intersection. Okay, 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 so this intersection could happen. Why? Because see because this blue line has crossed through the red line. Okay, so this thing can happen only under you know under these conditions. Okay, I think I should maybe I'll sort of emphasize this. So this angle was our 90 minus alpha. Okay, and uh, this angle was our 90 minus beta. Okay, so you see that if this angle plus this angle is more than 90 degree, then the two lines cross each other, and there is going to be intersection. So the condition for the two cones to intersect is has become very simple. So that is the 90 minus alpha plus 90 minus beta should be greater than or equal to 90 degree. So this is the condition. We can show that this condition would be equivalent to alpha plus beta should be in this case less than or equal to 90 degree. So if this condition is satisfied, then the cones do intersect. Okay, so this I mean I'll just try to split it into three situations. In one case you have alpha plus beta less than 90 degree, strictly less than 90 degree. In other case alpha plus beta is equal to 90 degree. In the other case alpha plus beta is greater than 90 degree. Okay, so here of course the cone intersection is not possible. We will not have a feasible solution. Here the feasible solution is possible. So this is the margin between those two. Okay, I mean margin between say existence of solution. uh, so no margin between this situation and this situation. So actually what actually happens? Okay, um, uh, will there be any line which is the common line between the two cones? Okay, if it is so, what is special about that line? Okay, and this is something I want you to answer. Okay, so that is the purpose of this short video. Thank you for your attention.